All right. Good morning, good afternoon, or good evening, everyone. I am extremely honored, grateful, and humbled that we have with us today the one and only Mr. Gavin Wintz. Now, I would like to say for the audience who will be watching or listening to this afterwards that my respect and admiration for Gavin's work over the years in various fields, as a matter of fact, is uh, unparalleled because it's absolutely phenomenal in my humble opinion, mainly because I've also been able to take a lot of Gavin's work and not so much replace as much as interpret and then incorporate his work into even some of my own. So without further ado, Mr. Wintz, how are you, sir? And thank you so much for coming on today. The floor is yours.
I'm doing really good. How are you doing?
I'm doing good, man. Thank you so much.
So, what I would like to do is introduce your audience to EXISTICS and where it comes from and how it came about. So, let's start with my famous analogy story, right? So, when I was about 16 years old or so, I was at my grandmother's house and we were discussing, does time go by faster as you get older? Just kind of an off the cuff conversation, something that I would do, right? And my grandma said to me that time goes by so much faster for her when being at the time she was in her 90s. She said that she could practically watch the grass grow. Now, what happened is all of a sudden, for whatever reason, I realized there's actually a dilemma. And that is if two people are engaging in some type of an experience together, whether it's a conversation or observing something, right? But they experience time at different rates of the passage of time, you have a break in continuity because one person would be further along the conversation than the other. So how can interactions exist? How can conversations happen if people are in different time frames, right? So, and mind you, at this time of my life, I didn't really know much about physics. I knew basic physics and saw a lot of Carl Sagan shows and things like that, but I didn't have like the deep mathematical background. And because I'd never heard anyone discussing relative rates of the passage of time in relation to our experience of time, this seemed like something that was unexplored. So I went down that rabbit hole. And ultimately, what I end up creating is what I call existics. And existics ultimately is the theoretical backdrop to resolve that issue. So let's go a little bit further into the future. When I was about 19 years old at UC Davis, and I'm in a philosophy of physics course learning about special relativity. All of a sudden, I see, holy cow, Einstein was faced with the same situation where he has two observers in two different frames, two different reference frames, experiencing different rates of time. And this is the famous twin paradox, where one of the twins accelerates away and comes back, and because they are an accelerated frame of reference, time goes by slower. So you have a differential in time, so that when the twins arrive, one's older than the other. The thing that stood out to me, though, was that there was a fundamental missing aspect to special relativity that ironically existics captures. And what that is that, and the best place to look at that is at the midpoint in the journey. So let's say A is the one that stayed on Earth, and B is the one that took off and traveled. Because B is going through a slower rate of the passage of time, it's actually on a different timeline than A. So once you have relativistic motion and you have two temporal frames of reference that are flowing at different rates, you actually have to make two timelines. And so what's interesting is that if existics is true, then what that would mean is there has to be a situation where in special relativity, there is an expected measurement of a particle to arrive at a certain time, but from the measurers, from the observer's perspective, it actually showed up early. So
Can
when
I
the
ask?
yeah, go
So
ahead.
sorry, Gavin, if I don't mean to cut you off.
Mhm.
Can we, for the audience to visualize, can we envision the separate timelines as sort of old film reels, if that makes
Yeah, we
sense?
could do that. And let me pull up. I've got a graphic I can pull up. Let's see here. Let me, where is it? Okay, so there's the EXISTICS one. So let me just show the EXISTIC
Please,
stuff.
absolutely.
Mhm.
And then please continue on wherever you see fit.
Mhm. Okay, so this is from my, and I should drop these well, I should give you these documents so that you can post them in the, I always get Zoom and Telegram mixed up. One second.
No
Okay.
problem at all.
All right, here we go. Okay. So the way EXISTICS works is that you have, so here's your two observers, A and B, right? And what's presumed is that this is the objective frame of reference relative to A, and this is the subjective frame of reference. Now, since we're talking physics, let's temporarily ignore the subjective frame of reference and just know that it's there. So A and B both have two different objective frames of reference, meaning they they don't actually share the same objective reality, if you will. One of the presumptions of existence is that there actually is no objective reality in the sense of space and time. There's essentially just the sea of infinity that we're inside of. And our relations with one another is what we would consider to be objective reality. But it's really just the combined relations between two interacting objects, people, what have you. So because of this, you can have two different timelines or two different rates of the passage of time relative to A and B. So so this gets into the reference frame stuff. So what you have is you have, so okay, slow down a little bit. So A and B are defined in terms of their relation to one another. So A is A relative to itself in combination with B's observation of A. And B is B's relation relative to itself and connected with A's observation or relative frame of reference of B. So let me give it. So here you go. So what you have is, so this would be A's reference of B, right? There's A's reference of B relative to A, and there's A's reference of B relative to B. You would also have B's reference of A relative to A and B's reference of B of A relative to B, so on and so forth. So this is how the relative frames of reference become entangled with one another. So the A and B are both dependent on one another in a certain respect in order for their interaction to be able to occur.
If I can add to that, Gavin,
Mm-hmm.
just in real time here for my audience knows that I speak quite often about the Casimir effect when you just take two metal plates and
Mm-hmm.
confine a certain point of quote unquote the vacuum. And I just want to say that your diagram above there does a beautiful job of showcasing how the Casimir effect could induce in the center point relative to the two parameters of the
Sure.
plates. That
Like
same
for
effect.
instance, yeah, and to take exactly what you said and expand upon it, notice that okay, we've got A relative to B, B relative to A, right?
Right.
Well, if you're really thinking about this, that's going to lead to an infinite regression of A relative to B relative to A relative to B, back and forth infinitely. So this is where, ironically, in the situation you brought up, if you were to apply this to physics, if you had two plates close enough to one another to where you could create what I called an identity crisis quite literally being a superposition of both what I call the inclusion principle and the exclusion principle. In that situation, which we'll get to, A and B are no longer distinguishable. So you have a superposition of them being both the same thing or not the same thing, depending on the frame of reference. So in
Love it.
your situation, what it is you've created an identity crisis, which then allows this iteration to occur. And that iteration could be mathematically converted into the push or the pull, depending on which frame you're operating on, right? Like, do you have the higher rate of the passage of time in between the plates or on the outside of the plates?
This
So,
is I love it. Thank you so much. This is awesome.
so this is, again, this, sorry to scroll through this so fast, but existics quite literally is a study unto itself. It's existics is the study of the laws that govern existence. So if you really want to have a theory of everything, you actually have to account for extraordinary metaphysical issues that arise in language, in mathematics, in our understanding of what it means to have identity, right? And then that has to then be projected into our physical understanding of the world. And so one of the ideas was, if this very interesting scheme I call existics is true, then there would have to be mathematical equations that could be derived from it that would then have some sort of physical phenomena that goes outside prediction, that when observed would match the mathematics of existics, right? Okay. Yeah, this is pretty intense stuff. Let me just kind of go over the axioms really quick. So like,
Please,
this is
please.
how existics goes. So the first assumption is existence is. We're just going to presume there is a such thing called existence, and it just is the case. Therefore, something must exist, right? Pretty simple deduction. Something is not nothing. Something is not everything. Something is one or more things. So from that, it would follow, for something to exist, it must be an interaction with some other thing that exists. So this is where we get A and B. So notice that our first cause starts off with an interrelation between at least two things. So where this would apply in physics is, let's let's assume that we have some kind of quanta pop out of the vacuum, right? And let's let that quanta pop out of the vacuum at an energy state that is just at or below the Planck constant, right? So what that means is it's outside our ability to measure it. So ironically, what it would be is a superposition of both coming out of and going back into the vacuum. However, it wouldn't be able to know, right? Let's, from its frame of reference, it would know whether or not it was coming or going. So it would be a superposition of both. Okay. And that superposition of both is essentially the the baseline from which physical reality emerges. Okay. So in, let's say, QCD, this concept can quite literally be replaced with the axion and the theta parameter that's used to smooth out the time invariance issue that happens with QCD. That can be done with this concept of an identity crisis, but at the lowest potential
Just
state.
to clarify, when you say QCD, you mean quantum chromodynamics pertaining
Correct.
to the study of colors in the vacuum.
Correct.
Right, right.
Correct. Ironically, existics works. I was able to apply existics to quantum chromodynamics first. That was the first place that I was able to do it. And then slowly I was able to then apply it to electroweak. And then once I'd done that, I realized that ironically, charge, spin, and momentum can actually be accounted for using a three-dimensional time model. And when I did that, what's kind of funny, and I'll show this to you. Let's see here. Did
When you
my
say three-dimensional model, could we potentially, and I say this more for my audience,
Can
could
you
we,
see this?
yes, yes.
Okay.
Could we view that as your sort of Z pinch, your XYZ on the Cartesian plane, but the Z is a third new dimension, so to speak?
Okay. So the way I do it, right, is I have your traditional metric where you've got your X, Y, Z, and then your temporal component with an imaginary extension, right?
Right.
Okay. But I do the same thing with three temporal components and then one spatial with an imaginary extension.
I love that.
You see what
Wow.
I'm saying? So what you
Yeah.
can do is I can condense this. So I could just turn this tensor into a vector if I wanted to, right? And
Right.
plug it into here. Or I could condense this tensor into a vector and plug it in here. Now, up here, this is the super advanced stuff. I don't even touch this ever because I haven't been able to even get there yet, right? But notice you got observer 1, observer 2, and observer 3. And then the fourth component is the spatial temporal interrelation between these two metrics. So what I finally realized, strangely enough, is that I actually independently derived quaternions, not even knowing it. So what this is this is actually the proper way to apply quaternions to physics. It's quite interesting because what happens is the individual is quite literally centered on the unit quaternion where the value is equal to 1. So basically, if two observers or two objects are the same, well, then that's because A over B equals 1. They're one and the same.
This
But if they're
substantiates ancient philosophers' work when they've said over the decades or the millennia rather, you are the center of your reality, literally.
right. And so
Right.
it's a trip is the quaternion mathematics actually captures that. So what you could think of so let me go back to the existics diagram real quick.
I love that sketch, by the way, of the face of the person. All of them, though, but that one was very well done.
so 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 what it would be is so he's the unit quaternion, right? He's the 1. So this would be the 3D space projected into the one rotation of the quaternion, where if you rotate it the other direction, you get the 3 temporal dimensions here. Because strangely enough, 3D time works quite well with our internal um, phenomena mechanisms, but it also does the same thing with particles. So what's interesting is to really understand that what we experience as qualia or this internal states, objects have as well. But the way an object has it is it's not a conscious experience, rather. It's the frame of reference of which the parameters exist that allow it to maintain continuity in relation to other objects, if that makes sense. So you could consider an object's unit mass pertaining to having mathematical components that you could consider its subjective aspect, but the objective aspect is how that interrelates with other things objectively. So it's extremely much more abstract with objects, but since we are things in the world, we can use our own experience and how we relate to the world as a way to understand everything else around us. So it's
This
quite
is like the coolest description I've ever seen, even from a philosophical standpoint. I'm just having a blast at the moment. So thank you.
so let's see. Okay, so let me show you the math of existics. This is the crazy stuff. Okay, like
Right.
I don't even know how I did this. All right. This is a whole discussion in and of itself.
Can I ask before you start, did you happen to use your intuition looking back?
It's all this is why this is such a slap in the face of
Mm,
the modernist
right.
physics community.
Right.
This was 100% intuitively derived. Okay.
Right.
You could even say that there were like, I don't want to say paranormal because I don't want to put myself in a box, but, you know, spiritual experiences, whatever you want to consider, deep meditation, basically going deep inside if you really want to know where a lot of this was built out, was inside lucid dreaming states. Okay. So what's interesting is I'm modeling out how the subjective frame of reference pertains to objective reality through going into lucid dreaming states. Okay. All right. So let's go to the equation. So again, A and B are two different things, right? And we're going to let the mathematical relationship between A over B, when A is the numerator, be N, and then we can flip it for its inverse and get U such that U times N equals 1, right? Pretty basic, simple notation.
Can I just say very quickly, just because
Uh-huh.
this stuff is exciting to me, to add to your is exciting me rather to add to what you're saying here. This also speaks to me with respects to the Pauli exclusion principle with the half
100%.
integer electron spin. Right, right.
It 100% there. And what I'm hoping to is that I can, because if I can get through enough of this stuff, what I'll show you is how to deal the solution to the measurement problem. Because I was on the phone with okay, one of my colleagues that helped me develop all this stuff. His name was Harold Dean Brown, one of the inventors of the microchip, worked at a company called Zilog. I had the opportunity to speak with his colleague, Federico Fagan, who's essentially the inventor of the microchip. I spoke to him about a week ago or so about these issues. And what was really interesting about the conversation, well, I just lost my train of thought. What did you mention? Because you said something that caused me to go that
The
direction.
Pauli exclusion principle, the half integer spin. So half of the electron would stay in this reality, and the other half would sort of dissolve into the ether, the vacuum, whatever you'd want to call it.
Okay, what he threw at me was, how do you deal with the measurement problem? And I hadn't thought about this for a while because you got to realize Existics is quite literally 27 years old. Okay. And the application of Existics to physics is quite literally 20 years old. So sometimes I have to go back and go through my notes and go, oh, yeah, that. Right. And sometimes when I do that, I have oh my gosh, I didn't quite think that through. And now I'm looking at it. Something I like to do is forget all of my material. So you'll see that I put all these like 3-hour videos of me showing how existics relates to physics, right? 10 years ago. So I'll go forget it all, then go back and watch it and try to rederive it. Because for me, that's the easiest and cleanest way to find my mistakes. Because what I notice with physicists is because they spend so much time on their own material, they're lost in the forest. They're staring at trees. They can't ever, so they'll just keep repeating the same mistakes because they haven't taken a break from it, distance themselves from it to then come back at it and look at it with fresh eyes. So what Fagan made me do was go back and look at the measurement problem. And having done so, it's like, oh my gosh, it's right there in front of my face. So that's where we'll go. Okay, so when we think about this, okay, if we're so let's say A's grandma and B's me. We want to find out where grandma and I are in relation to each other in our conversation, right? Grandma's experiencing time so much faster than me. How do we calculate it, right? But in order to calculate it, we have to take into account the infinite frames of reference, the iteration that happens where if there's a grandma relative to me and a me relative to my grandma, then there's a me relative to my grandma relative to my grandma, and a me relative to my grandma relative to me relative to my grandma ad infinitum, quite literally like when you hold up two mirrors and you get that infinite regression of reflections in both directions. But what you could say on one side of the mirrors is that's relative to A, and then on the other side of the mirrors, that's relative to B. So what the existics equations are doing is linking all those different iterates in relation to one another so that you can have invariance in their interactions. So the way I came to this, and I don't know how, was to use a very peculiar form of continued fractions. Now, usually, and what this is so this is A, this is B relative to A, relative to B, relative to A, relative to B, relative to A, relative to B, relative to A, so on and so forth. So this is from A's perspective of the iteration.
I just want to say, I'm so sorry, man. You're exciting the heck out of me with this stuff. I was just working on a paper this morning pertaining to the magnetic vector potential squared and how there's gauge invariance, even as you go fractally along you could say the throat of the wormhole.
You want to know what's freaking crazy?
Mm,
On one of my videos, and I could show it, I do a proof to show because, and to jump ahead,
yeah.
um, when you actually solve for where A and B are in relation to each other and you plug those numbers in, they have the same ratio as A over B.
Right.
So what's trippy about that is that actually means they're invariants. It also means that I could use a kind of a bootleg geometrical proof to show that this is another way of deriving 90-degree angles. So strangely enough, this is a way of using continued fractions to derive right angles. It's quite literally an alternative to the Pythagorean theorem, but with continued fractions. So part of the reason why I'm emphasizing this is these equations by themselves are extraordinarily unique. And over the past 27 years, I've never seen anyone else having done these.
And can I
So go
can
ahead.
I say even more specifically for my audience, for the portion of the audience that is not as scientifically oriented or mathematically, what, and please correct me, Gavin, if I'm wrong, what we're saying here is when we say gauge invariance is a fancy way of essentially saying there is perhaps in practicality an underlying energy or substrate at the quantum level that interlinks all material phenomena, regardless of where, how they're structured, etc.
Right. And I
Right.
actually could show that that's a particular interrelation between two temporal components. So where was I with this thing? Okay, so all right, so this basically mathematically represents A relative to B relative to A relative to B relative to A in relation to A. Okay. And then here's the other component, B relative to A relative to B relative to A, all of that in relation to B. So notice that these are strangely opposite equal in a very fun way. Now, what's a trip is, okay, so I want to solve for n star, which is basically this. Now, what's neat about solving for this is because this goes on to infinity, I can remove this, I could remove this, but this will always be that same value. So strangely enough, I can actually pull out n prime and just put n star because since this equals n star and since I'm adding it up there, a plus n star over b equals n star. Do you understand what I mean by that? Okay. So I do this. So now I'll just substitute n star in. And so when I just go through the basic just algebra, I'm able to reduce these continued fractions to very specific values. So the major breakthrough here that Dean Brown was shocked at is that everyone thought these were just going to blow up and go to infinity, that those would diverge, but they don't. They converge to exact specific values. Okay, so let's show this being applied. And then, okay, so then what you do is you take the n star, subtract 1, and add it to A to get A. And then you take, and okay, I'm jumping ahead. All right. So when A equals B, the identity, and I call this the identity constant. When A equals B, the identity constant is 1. When A and B are not equal, we use the continued fractions and we get the number I, which is just greater than 1. So this serves as a way to have invariance when we don't have when we've drifted away from simultaneity, quite literally. Okay. Okay, so that's the I here. Where if these were, well, okay. All right, so this is how you find A and B in relation to where they are. So let's say when I'm 20 years old, right? And so grandma's 100, I'm 20. So I add the change to grandma, find out she's actually 105.25 when I'm 20 relative to her, or I'm 19.125 when she's 100 relative to her. So here we go. So suppose we have two persons, person A, 100 years old, person B, who's 20, right? So here they are. So A is 5 units is 5 to 1 in relation to B, and B is 0.2 in relation to A. So for instance, 1 minute to B would be 5 minutes to A, or 0.2 minutes to B would be 1 minute to A. You see? So then what we do is we bring, and this is where Einstein's stuff actually is consistent with the existics, but existics shows actually this isn't correct because that we need to adjust for the infinite relations, right? So that's where the continued fraction comes in. So when I do the calculation, I get, instead of 5, I get 5.2632, and instead of 0.2, 0.1980. So then to find where they are in relation to each other, so we subtract the identity constant from n star and add that to A and get 1.04.2211. And then we do the same thing for B. Okay, so here's the ta-da, right? Let me move this thing. Okay. So at the event relative to A relative to A is 100 units of age. B relative to A is 20 units of age, and B relative to B is 19.1559 units of age. So at event A, so here's A experiencing converse. Yeah, I'm so old that I can see grass grow. And I'm like, really? That's crazy. Well, relative to grandma, she's talking to me relative to her, but me relative to me is actually like, I'm not there yet in my timeline. But then in event B, which is when I'm having the conversation with grandma, and she's like, yeah, I'm so old I can watch the grass grow. I'm like, really? That's crazy. When I'm experiencing it, she's actually at 1.4, at 104.22 in the timeline.
So they're proportional and they move together.
Yes.
Yes, yes, I see it.
So what's weird is this is a way to have invariance without simultaneity, because obviously simultaneity has been broken. I've got two different events, but I'm able to maintain the invariance by using these equations. And what makes the invariance possible is the fact, do I even have it? This essay's so old, I don't even think I have it in here. I'll have to draw it. Hold on 1 second.
You're speaking my language, by the way.
Here, it's right here. So, and this is something that I didn't even realize till maybe 15 years into this stuff. But A over B equals N star minus I over I minus U star. So sorry for this, okay. So what it is the adjustments have maintain the same ratio as the original values, right? So let me
Right.
graph that for you. And this is where this is one of the most exciting parts of this. Okay, so here's N star minus I, here's I minus U star, here's A, B, A asterisk, B asterisk. So here's what you get. So here's the point of A to B, right? So that's where we have the 100 to 20, right? So that would have a slope of 5. Well, A star in relation to B star maintains that same slope angle because this over this has the same value.
You're,
Okay, now,
yes, yep, yep,
what's cool about this is really simple math. Now,
right.
here's where this gets absolutely mind-boggling. If I take this triangle and just rotate it down like this, right?
Right.
To basically do a basic geometric proof that that's a right angle. Guess what this triangle quite literally gives me?
The other side.
No, the same math for the unitary triangle in quantum in whatchamacallit, what's it called? You know what I'm talking about? The unitary triangle for the Cabebo angle.
Oh my gosh, that's even with that's also the
The
Carl
Yang-Mills stuff.
yes, and even the Roger Penrose event horizon of a wormhole.
Exactly. So what it is I can then take these equations and plug them into QCD, QED, and electroweak theory.
Right.
And then this triangle can account for broken symmetry.
And the stabilization of it.
Correct.
Yep. Yep.
Okay.
I want to thank you, by the way, for because you those words you used there are the exact words I used in my presentation at APEC, and I want to thank you for letting me put your existics works in one of my slides there.
Oh, absolutely. No, that's okay. So now let's go to the adjusted twin paradox, because this is when we start getting serious, right? Okay. So so here's your generic twin paradox, A and B, right? B is gonna hop into the rocket ship and go. And here's your traditional Lorentz transform to calculate how many units of time A and B have experienced in relation to one another. But notice this doesn't account for the infinite frames of reference that EXISTICS does. So we're going to go ahead and apply the EXISTICS equations to the twin paradox. And we get the same situation where there's a future, a present, and past in relation to each one. So when A relative to A is in the present, B relative to B is in the past. But when B makes its way up to the present, A is in the future. And this isn't the right diagram for that. Here's the right diagram for that. Okay. So here we have at the midpoint, B's moving at relative frames of reference. B's moving at with relativistic motion because it's an accelerated frame. So we have to apply the Lorentz transform to calculate for that. And then we apply the existics equations. And then this is what we end up having happen. A is at a faster rate of change than A relative to B, and B is at a slower rate of change than B relative to A. A comes from a faster rate of change compared to the initial B, and A relative to B is at a slower rate of change compared to the initial A. The result is that B arrives having a faster rate of change than predicted, and B arrives at an earlier time than expected. B is older than expected, arriving early. This is an additional time displacement for A and B relative to their common center of time, unaccounted for in relativity. So the punchline is down here. Where are we at? Okay. Therefore, when B finally arrives at A, he knows he took longer than he should have and says, "Sorry, I'm late." However, A looks at his brother with astonishment and says, "Oh, you've arrived early." To both of their surprise, the clock that B took with him reports that B took longer to arrive than predicted. Also, the clock that A has with him reports that B has arrived ahead of schedule.
To
So
me, if I could
basically,
say personal interpretation, to me, this speaks to the idea of the now, creating the future and then generating the past and or vice versa.
okay, so this is where I need to get you to modify your understanding of time to understand how the present comes into play. Because once you can actually understand time from a three-dimensional perspective, all of this clicks. Okay. Now, when I say three-dimensional time, I don't mean the past, present, future in three orthogonal directions. Okay. What I mean is that time itself actually has three components that can be broken down into dimensions. And so I'll go ahead and present those.
Love this.
Right? Isn't this fun?
Oh,
Okay.
extremely. My audience, I have a feeling they'll love this very much.
Okay. So can you see that? Can you see the YouTube
Yes.
video? Okay.
Yeah.
All right, so we'll go ahead and mute this. By the way, you can go get a lot of the stuff off the EXISTICS 101 page. That's where I have a lot of this or my YouTube channel. Okay, so here you go. This is conventional time, right? Ignore the XY plane for a moment and just think of this as linear time, right? So what we're going to do is we're going to go ahead and now we're taking into account the timeline relative to A and the timeline relative to B. Since A and B are not since A and B are experiencing different rates of the passage of time, they are not tracking along the same temporal
Sorry,
timeline.
Gavin, the screen froze right when you went full screen.
Oh, okay. Let's see. Here's what I'll do. I paused it. Maybe is that what you mean? Let's see.
It wouldn't right when you went full screen, I think it opened a separate window.
Oh, okay.
Yeah.
Wait.
Um, oh,
Oh,
let's see now.
hold on.
Sure.
Let's see. Technical difficulties. Please stand by.
No problem.
Can you see that?
Yes.
So you're saying if I make it full screen, that
It,
creates a problem?
yes, yeah.
Okay. All right. Well, so be it. Okay. You
This
know, I
I
can do
can see. Yeah. Yeah.
it. All right. So right here, this is linear time, right?
Right.
All right. So as soon as B gets in the rocket ship and takes off, A and B are no longer sharing the same rate of the passage of time. So we now have two timelines rather than one. So the green line is relative to B and the blue line is relative to A. And so what the existics equations would show is where along a center of time line where they would be in relation to one another. So, for instance, when B so you could draw the little triangle right this, right? And so what it'd be is when A is here, B is slightly further behind, and then when B catches up here, A is slightly further ahead. So the existics equations allows you to basically drop 90-degree angles from these two divergent timelines onto linear time to show where they would be in relation to each other in a center of time frame. Does that make
This
sense?
not only that, but this also, in my opinion, satisfies what you'd call the Stokes parameters for what are called monochromatic Gaussian beams. In other words, uh, essentially unifying the codification of Maxwell's quaternions in
Oh,
electromagnetic
big
theory.
time.
Yeah.
Big time. That's why if you think about it, the three-dimensional time, so 3 time plus 1 allows you to bring the quaternions in. And it's the quaternion application of 3D time that accounts for charge, spin, and momentum. And just real quickly, in this, there's 4 charges. There's plus forward, plus reverse, minus forward, minus reverse. And because forward time is slightly ahead than reverse time, what you can have is a situation where you can collapse where a forward moving plus charge is equivalent to a reverse moving minus charge. The plus charge is going to collapse the probability of the minus charge because it's further along in time. And we're going to come to that in a minute.
And vice versa, I would take it.
Uh-huh.
Right. Yeah.
Okay, so let's go ahead and bring in the third dimensional time passage. Okay, so what we have here is A and B are experiencing different rates of the passage of time in a period present time plane. So what linear time can be broken down into is periods per present moments, right? So the present component you can think of as so this component here would be an ever present moment, right? So you could have, and then this would be a single, you'd have the past, present, and future within a single moment. And then you can slide the linear timeline either direction. So I can slide it this way, right? And slow time down, or I can slide it this way and speed time up. So I can quite literally bring the Lorentz transform and set it equivalent to different slope angles of periods per present. Does that make sense?
Big time, absolutely.
But not only that, I also have a vertical component where I can change the rate of the passage of time separately. So this is where variable speed of light can come in, where I can maintain the speed of light in the period per present plane, but I can have faster than light frames of reference based on varying rates of the passage of time. So
This,
for instance,
yeah, yeah.
and this is extremely significant when it comes into symmetries because I can apply the unitary triangle to the period present plane and account for quantum chromodynamics, gauge theory, etc. But I can then bring it up here and account for new things that we saw with the mass of the W boson at Fermilab. The change in mass can be attributed to a rate change in the rate of the passage of time with the vertical component while maintaining the gauge invariance on this plane, even though you've broken mass symmetry. So,
Yep. This is the man, you've made my whole day with this stuff. And I love the visuals, by the way.
so here's looking at it in relation to passage and period. So so here's B having traveled in the rocket ship, right? Here's A having stayed at home. And here's the moment of when A is here, B is here, and when B is here, A is here. And then this would be the center of time frame of reference where where had either of them not moved, you would have the same slope angle as them having moved in relation to the potential. So, so that's 3D time in a nutshell.
That is, I'm in full agreement with you, by the way, with everything that you've put here with respects to time. When people talk about, for example, oh, I had an experience where I was missing time, I wouldn't necessarily say it was missing so much as it was dilated in the way you presented.
Exactly.
Right, right. I mean, this is awesome. I just wanted to thank you for, well, first let me say to the audience that Gavin and myself have agreed to do sort of a series laying this out, and I will say on the record here that I'd love to, without putting you on the spot, I'd love to incorporate your existics in some of my upcoming papers, and of course, reference you and cite you and all of that as a co-author and all of this. But this is absolutely incredible, and I want to thank you for sticking with it because it really unifies, it provides an answer to quote unquote reality, in my opinion.
Right. So we'll leave with this, right? So let's jump to the measurement problem
Sure.
really quick. So the problem with the issue with the measurement problem is what happens to the superposition once a measurement's made, right? Because the superposition will give you one probability, but then you have to adjust the equation once the probability has happened because you can't have the missing aspects. So you adjust it. So what's the justification for the adjustment? So okay, so let's go back to that initial condition, right? So in the initial condition, we have, and this is how I'll draw it. So we have a quantum fluctuation, and we can't tell, is it coming or going? Is it popping out of the vacuum or is it going back in? Because it's at a small enough distance that it's unmeasurable, right? So it quite literally becomes the superposition of two potential states, a going state or a leaving state,
Due to
right?
the third time derivative, would you say?
Yes.
Yes. Yeah.
Do you see what I'm saying? Exactly. And so what it is the, and where this is fun is the present time component is what's pointing at us. Okay. And that's where everything gets confused. So we're like, how can particles be entangled that are very far apart? And it's because they're temporally in proximity to one another.
Could
The present time coordinate allows things to be temporally in proximity, though spatially separate. And so what entanglement is that they're indistinguishable temporally. So two particles that are entangled are sharing the same time, and that's why they're indistinguishable, but they're spread out over space because of the different rates of the passage of time.
can I
And
so if
this
I
is,
oh
go
sorry.
ahead. No, go ahead.
Oh, well, I was just going to say to add to first off, let me just say, and I'm not saying this because you're here, because I do disagree with when others come on my show, but everything you're saying here, I'm in full agreement with, also because it literally adds up to my numbers as well, as we've discussed in some group
Mhm.
chats some many months back and all of that. But please tell me if this is a bad example for the part of the audience that is not as mathematical or scientific. Imagine sitting on you have two TVs set up on the wall separately but on the same wall in your bedroom, and you have one remote control that controls the both of them, but as you switch say to channel 10 on the right TV, then on the left TV it automatically goes to channel 1 and vice versa, but they're both being controlled from the same controller.
Exactly. And so
Right.
the mystery would be, how can these things switch instantaneously because it violates speed of light? The problem is that general relativity and special relativity only have one time dimension.
Right.
And that is the problem. So once you bring the extra time dimensions in, what you can do is you can use the present moment as a as a vector,
Right.
so that what you could do is, so this is how this stuff gets trippy, right? So picture, here we go. Let me draw this really quick. So we got past, present, and future. Okay. So notice the present can be a dimension orthogonal to period. So periods are moving from the past into the present into the future, but we have, it's so hard to do this.
Oh,
We
it's all good.
have all the horizontal lines are different present moments, right? But
Right.
we can assign present moment one, present moment two, present moment three to different spatial coordinates. So then that becomes your probability distribution of the superpositions, because you can use the spatial component juxtaposed with it to give you the variation. So the way I like to think of the present moment is a series of a photo of the same moment spread across. So whereas going this way, it's the each image as it changes. So this would be your video reel, your
Right.
film reel, where this would be the same frame repeating over and over.
And the drag rate would be going faster than the speed of light in your now.
Correct.
Right.
Right? But you can attach spatial components to this. And even though it's the same moment, you can change the symmetry of the spatial aspect. And so basically, this is where all the weird quantum stuff is happening, is that it's all happening along the same coordinate. So by bringing in the extra time dimensions, it allows simultaneity to be a line that you can you can distribute things across and still have them in proximity to
With
each
that,
other.
and also not only that, but without loss of generality as well.
Exactly. Like
Yeah.
there's no loss of conservation of energy, even though simultaneity can be broken.
Can I just say that it is of my humble opinion, you also describe the principles fundamentally of how UAP or UFOs operate? In
Do you want to go that direction?
If you like, I was gonna ask kindly if perhaps we could wrap it up in the next handful of minutes, just because there's so
Yeah.
much quality stuff here, and
Okay. Yeah,
I
yeah.
will,
So what we
yeah,
could do is we need to have a deep dive into UAP because there's two things going on, even though there's kind of one thing going on.
right, right,
We have to acknowledge that there is the laser-induced plasma technology that can be used to create a
yeah,
a holographic image
yeah,
in both real space and on a radar for
right,
purposes of which is the actual target, which isn't,
right,
right?
right,
It's
yes,
like a nut and shell game, right?
yep,
And I believe that's what the Nimitz was seeing was basically laser induced plasma. Like these weren't discs breaking the laws of physics. This is just someone with a freaking laser beam pointing it around quickly, right? Now,
going
the
back to
reason
the
why,
converter example with the TVs,
yeah,
right,
exactly. And the
right,
reason why I can speak to this at the time that my dad was the director of marketing for Lockheed Martin out of Norton Air Force Base, okay, after he worked at a company called Tracor Aviation, which had contracts off of El Toro Base, the purpose of what he was doing was they were creating drone aircraft to shoot down. Okay, so that's what my dad's job was in the 80s. All right.
right,
So let's jump to the 90s. And my dad's like, hey, I want you to come to the base. I want to show you something, but you can't talk about it. Now, technically, I can't talk about it, but it's in the public, so I can. So I go to my dad's base. This is 1992. And I go in there, and there's Pink Floyd setting up all of their laser equipment using quite literally Lockheed Martin's laser technology so that they can do their shows. So if you stop and think about it, the irony is that the tech that I was observing Pink Floyd using for their laser shows, because watch, they're able to get those lasers to coordinate and all that stuff. Well, that would be the same tech that if you just added a little extra to it, you could then make these glowing objects in the sky that are basically like, have some invisible laser spectrum
right,
interface and create plasma in a visible
spectrum,
range.
yeah,
And then you're just going to see that object. And what I'll tell you is because I'm kind of comfortable talking about some of these things, I'm going to have to one of these times go deep into how a friend of mine used to get trolled by this stuff. Because what we would do is we'd go out and kind of like try to see things, right? Like he was more crazy than I was. He would drive out to Area 51 and literally climb up the mountain and camp out and all this shit. Like he got round out a couple times, right? Like in the 90s, that's when there's no Area 51. So when we're in our 20s, it's like, oh yeah, well, let's go find out. Well, what's funny is when you go poke around the bases, right? They'll poke back. So strangely enough, we had situations where we were being followed around by glowing balls that oddly enough had white vans with them. Wherever the glowing ball went, the white van went, right? And
right,
we were freaked out, right? This is
right,
super sketchy stuff. Well, spoke to a friend who used to work at El Toro, who's still involved in the Air Force stuff, right? And he said, yeah, we would totally do that. When people would poke around, we'd quite literally troll them with the very thing that they thought they were looking for to just run the curiosity seekers off. Now, why that's kind of funny is my grandpa, he was high up in the NTSB. He had clearances, so he was one of the guys that when the top secret aircraft crashed, my grandpa would go do the recovery. And one time he came to me and he said, Gavin, there are no aliens. It's all us. And we have guys out there that will say it's aliens to create the psyop essentially to get the curiosity seekers on down the wrong path so that we don't lose technological dominance. So what he tried to, now whether aliens exist or not, let's make that a separate issue. What he was making me understand is that most of the UFO stuff is psyop to create ambiguity as to what the technology actually is, and to basically gaslight the enemy.
And to also drive, I mean, to the point of psychologically driving certain people so insane with lie after lie after lie that
Exactly. Like that one case, I can't remember his name, but the one guy,
Paul Benowitz.
yeah, I think
Yeah,
that's a perfect example of how that can get out of control.
with
You
you're
know,
talking about, if I'm not mistaken, Richard Doty, I believe, driving Paul
right.
Benowitz crazy. Yeah, there's a lot of people that actually, from various elements of the military, have come out and said they didn't like that he took it that far with
Yeah,
driving.
like scare
Yeah,
people off the base and have a little fun with it's one thing,
yeah.
but to then, screw with someone's mental states, like that's not cool.
I completely agree. And I just want to say that I'm also in very strong agreement with everything you said. I think that the vast majority of sightings can be explained from a not only from an existics perspective, but also from the fact that if this was something potentially that was tapped, say, in the 50s, 60s, hell, even this, let's just say the 70s, even though you and I both, I think we both know it was far before then, to apply that then to even inducing, say, an acoustic vibration into that plasma ball, you can then have now speaking plasma balls or orbs that will then
Well,
mess with people.
think about it. So, okay, let's go fuck with these campers, right?
Right,
So,
right,
like, you have your white vans pull up, right? And
right.
then the guy in the back who's got the remote control and everything, or however they're doing, because there's probably a million ways to do this, right? And then you just float a glowing ball over the campers, and then it's like, we are from another planet. We come in peace, right? You just completely trolling, having to hit the mute button because you're laughing. And now
Well,
you've got a group of people that think they've had a contact experience. So now you can have your CIA media personalities go interview these people, right? And start pushing this stuff on some of these platforms. And oh my gosh, right? And it's really just a very involved DoD psychological operation to cover up technology that they don't want people understanding how it works.
and it's unfortunate because if there is any type of interdimensional, crypto terrestrial, even extraterrestrial presence, forgive me if I'm leaving anything out, then it really, again, this it really messes with people's heads as to what's real or what's not, which is why I think your work does a great job of discerning, using both logic and intuition and a perfect balance of the two to discern what are we really dealing with here. Because if we were to think that laser beams are a fractal or mini simulation of light rays from the sun, then we then think from that perspective of, okay, what could be done after a laser beam is shot out in a, unfortunately, in a weaponizable sense. There's also the other side of that, in my opinion, which you perhaps would agree with, which is the medical healing aspect of this tech.
Mm-hmm.
But of course, that's seldom seen publicly.
Yeah, it's just one of those things, right?
Right.
Like are they really looking for a theory of everything, or is the theory of everything locked up in
Yeah.
DoD contracts and it's a national security risk to allow the deeper understandings of how
Right.
gravity works? You know what I'm saying? Like
I
what
go with the
kind of
second one. Yeah.
right? Like what
Yeah.
kind of weaponry comes out of a theory of everything? And so that's probably the reason why, in my opinion, the theory of everything's actually suppressed, not unknown.
Well, to add to your point, which I agree with, what comes out of it is the weaponization of the suppression of the truth.
Mm-hmm.
Yeah, and I would fully agree. But with that said, I'd love to wrap this up, but
Mm-hmm.
well, actually, no, I don't love to wrap it up, but I really appreciate the way you've presented and everything you've done here. And I would like to say to the audience that you folks will see much more of Gavin down the road. And please, Gavin, tell my audience where and how you could be found. As I said, this will be for the first week on the member side, and then it'll be public 7 to 8 days from today.
Mm-hmm. Well, I've got a YouTube channel. That's just Gavin Wentz on YouTube. If you type in Existics, which is literally the word exist, IC, right? Existics. You can find all material or existics101.com, or you can find me on Twitter and talk with me because I enjoy engaging people on this stuff as well. So
Awesome, awesome. Thank you so much, everybody. And again, for those that have not signed up to the Patreon, please consider doing so. Patreon.com/Generation Z, more so for when this goes public shortly down the road. And we'll catch everybody soon. Thank you so very much, Gavin.
Mhm.